Thanks so much for coming, everyone. My name is Gibbons. I'm head of customer success at Diagrid. It is a company that's backing the open source Dapr project. Just a quick show of hands, has anyone here heard of Dapr? Okay, cool. That's pretty
Anyone?
It's a graduated CNCF project now. And yeah, we're here to talk about cross-cluster, cross-cloud communication with Dapr Cilium.
Hi everyone, my name is Manuel. I'm a solution architect for a German consulting company called Codecentric. We are focusing on cloud-native software development and whatever that kind means, but therefore we're also making heavy use of Dapr in various customer projects. Hence, that's why we're here today.
Yeah, I forced him to use Dapr in all of his projects. Awesome. So since a lot of you have heard of Dapr, I'm not going to go super deep into the overview, but just a quick high-level 10,000-foot view for those of you that have not heard of it. Essentially, it is a set of APIs for building distributed systems. So, if you are writing your application in choose your favorite language on the top here, you can reach out to a Dapr sidecar or a process, which can run any of these different APIs or these building blocks. So essentially, if you wanted to take advantage of like asynchronous message communication with a message broker, you could use the Dapr PubSub API. If you wanted to do like durable execution with workflows, which is like super hot right now, you could use our workflow API and built-in workflow engine. You also get a number of cross-cutting concerns that are built in to the Dapr runtime. So things like security, like observability and resiliency. So you get MTLS built in, you get things like distributed tracing with built-in OTel, and like resiliency policy is built into your Dapr system. So instead of having to write resiliency within your application code, you can apply that at a higher level using like all of the configuration that Dapr gives you. It runs 99% of the time on Kubernetes in production, but you can also run on VMs or a ton of other hosting platforms listed on the bottom here. A quick note on components. So in order to add to this abstraction, we have the idea of what's called a Dapr component. And essentially what this is an abstraction on top of any of the infrastructure you might be reaching out to within your application. So if you wanted to reach out to, AWS DynamoDB for a state management or a key value API, you could use a Dapr component configuration file, and then instead of, putting the AWS Dynamo SDK within your application, you would use the Dapr APIs via a native gRPC or HTTP client, or use the Dapr SDK. And this allows you like some really nice, like a lot of niceties for like application development. We've had developers say that it saved them like 30% developer time across, I think that was a survey of over like 200 or 300 developers that we did, and that's like greenfield and brownfield applications. Typically, it runs as a sidecar. So, you're invoking the Dapr APIs via localhost, but it can also run as like a daemon set or just a deployment, depending if you're not sidecar people. So a lot of people aren't sidecar people these days. That's okay. So if you were going to reach out to, one of these APIs, for example, the service invocation one, you could use like the invoke endpoint, and then like in this case, call the cart service on the method order. And Dapr will do the service discovery and the invocation for you. This makes swapping the underlying implementations of the infrastructure super, super, super easy. So, for example, if I'm running in local development and I have this kind of super simple microservices architecture here. I have 3 services, one's doing like a service invocation, one's doing a PubSub communication, and one's doing a writing a secret to a local file. I do not have to change any of the code from going from local to, let's say, on AWS. All I'm really swapping there is those things I was talking about, which are components. So I can swap to AWS Secrets Manager or AWS SQS and DynamoDB without actually changing any of that code. Really nice for going cross clouds, which we're talking about today, or going cross environment. Quick note, what we're going to show for service invocation. I'm going to go over here because I'm really over there on that side. Yeah, for service invocation, say if you have 2 applications here and you are like doing an invocation between your services, of course you're going to have those Dapr sidecars living in between those services, and then again, built-in MTLS. There's a name resolution component, which again will invoke like kubedns if you're running on Kubernetes, or if you're running on something like virtual machines, you can use like console DNS. It has built-in MTLS and then observability for whatever your observability backend is. And yeah, that's pretty much it. And then publish and subscribe, which we're also going to show in a quick demo here. But if you have, again, 2 services wanting to communicate via like async communication using like whatever message broker you want, I believe we support over 20 message brokers these days. So there's a lot of these open source components, again, all written in Go, all available on GitHub. You can totally check out the source code. But this would be invoking the sidecar on the publisher side, and then it would go to the message broker. It's using the cloud event specification. So it's kind of, you can enable or disable cloud events if you want to. And then, again, still getting that full, complete end-to-end distributed tracing and observability. And then, yeah, this is all kind of wired together using what's called a component, right? So I have this component, which is just a Kubernetes CRD, and this is going to have, in this case, talk to pub sub Redis. And again, in this case, this is running on a Redis host that's running on my local machine, but this could be running anywhere, right? Your Redis cluster could be in Azure, in AWS, on Kubernetes, whatever. So again, you would just put those connection details into this component, and then Dapr completely abstracts the Redis SDK. Like, you don't need any of that within your code. You just use the Dapr APIs. So how does this relate to anything for cross-cloud communication? Good question. So Dapr versus service mesh is something that comes up a lot. I think I mentioned MTLS, which is something that you get built in with Dapr. And a lot of people are like, wait, I already have MTLS that's in my service mesh. So that's definitely, there are some overlapping concerns. And this is a question that we get all the time. So things, for example, like MTLS, distributed tracing, metrics, resiliency, those are all things you can also do with, choose your favorite service mesh. Now, if you want this more at the application layer, Dapr is definitely the right call for you, or you can use these things together, which is what we're talking about today. So for example, the things that Dapr does absolutely not do is any sort of traffic routing or traffic splitting. So if you wanted to do A/B testing or canary deployments with a service mesh, that's not necessarily what you can do with Dapr. Again, it's not running at that network layer. It's much more, think of it as an application developer tool. Yeah, but instead, right, you're gonna get all those different application APIs that I was talking about. So things for building workflow, things for building state, et cetera. And so with that, I'm going to pass it over to our service mesh guy, Manuel, and he's going to talk about Cilium.
Thank you. I'm not so sure about the term service mesh guy, but let's see about that. As you can, if you know me from some previous talks, for example, I did at KCD Denmark, you know that there are two hearts beating in my chest, right? On the one hand, it's kind of like the Dapr heart, which is why we're here. And on the other hand, it's also the Cilium heart. Given the current situation, I think Cilium is riding the hype cycle quite well, and I think there was at least two talks mentioning Cilium today, at least here already, so you can see where we are. But just for the super quick one-on-one on what Cilium is and why are we here. Cilium by itself has an implementation of a service mesh, no surprise here. And what they did very early is they built on the sidecar-less service mesh, right? So back in the days with traditional Istio, Linkerd, whatever, it was everything about sidecar. And as Alice said already, the sidecar train is coming to an end, at least for now, potentially, who knows. And they started super early on providing this sidecar-less service mesh experience. They do this because they use eBPF for kernel extension in the user space, right? So we heard about it, I think, twice today as well already. So there is a reason for it. And therefore, Raymond from Isovalent, which is the EMEA field CTO, likes to call it, Cilium is like the Swiss Army knife for Kubernetes networking. And it really is at that point in time. Because based on all the functions and all the capabilities they add, and there's this shiny image on the right, which I'm not going to read because you can do this by yourself, it can do a lot of things, really a lot of things. Not only can it do all the lower level networking, layer 3, layer 4, whatever you name it, but you also can use this with extra capabilities for layer 7 if you want to do traditional HTTP routing, for example. So it really is the foundation for modern networking. What we focus on today for this talk is the Cilium multi-cluster mesh or Cilium cluster mesh, whatever you call, whatever you want to call this, and this is basically the possibility to combine clusters together to let them act as one, right? As shiny and as fancy as this sounds, that's what it eventually comes down to. How this works is, since Cilium in itself is shipped as a CNI, right? So it's a container network interface, it can do all the crazy things on the networking level. And since it's using eBPF, it's really low in doing this. And how this works is they introduced a concept for, like once you wired clusters together, they introduced a concept called global service. So you can take one of your Kubernetes services, put an annotation on it, right, kind of patch the service with this annotation, mark it as a global service, and once it's a global service, the magic starts to happen. What happens in that scenario is, and I took this image from the source here, if you have two clusters, for this example, they could both be running on AWS or whatever. You have the Cilium agent running on each, which is the CNI at that point. And for the truth, there's a second component called the API mesh server, if I remember correctly. Those guys start synchronizing information about those exposed services, right? And if then one of the pods here wants to reach a pod on cluster B, the agent will intercept the HTTP request, rewrite it to the private IPs that you have in this cluster, and put it over either in tunneling mode through a VXLAN or per direct routing, depends on the case, puts it over to the cluster, and there the agent sees it again and can forward it to the actual destination. And this is pretty cool, because since it's following the normal way of traffic forwarding within the Cilium cluster, you get all the other benefits that you have at the same time, right? Like you still can enforce network policies, for example, or cluster-wide policies or whatever, just like everything. So it's really in the middle of communication and allows for cases like the multi-cluster model. If we look at the service invocation as like an example from what Alice already explained, from the Dapr perspective, there doesn't really change much or anything. Like previously, the Dapr sidecars would have communicated directly. Now there's the Cilium CNI in the middle, which enforces communication in either way, but it's totally transparent to Dapr at that point, right? So at that point, Cilium is more like an add-in that you put in the middle and that magically does things, and Dapr doesn't even know about it. So because this was a lot of theory at that point in time, let's pray to demo gods and hope that things don't completely break up. So for this one, what we want to showcase today is we took an example architecture having one application front end running on Google Cloud, which then calls through a gateway on two AWS clusters, where there is a gateway, which then pushes things forward through a message broker eventually, and there are subscribers on this message broker that is responsible of ditching the messages, which eventually is a Redis store. But as you can see, all services, no matter what, they all go to this one Redis on this one cluster because they can act as one. With that being said, let's look up some code. Oh, well, not some code, some structure. Here we go. I make this a bit bigger. Yeah, this is just chaos.
Yikes.
So, is this big enough? I think it is. I think it is. All right. Do you want to show before the application, and then I can do it? Okay. There we go with the good desktop. So we did a dummy application at this point in time, and you can select your communication types, right? We can either do service invocation or publish subscribe. We're going to start with service invocation. We just have some message types here, which are totally irrelevant, like it's just a type, and we can do some messaging. So we could do service invocation at that point in time. We just go for hello rejects.
I almost spelled that in German.
Almost, but I fixed it on the fly.
And then if you press submit, Manuel,
yeah,
I will just walk through. But so yeah, hopefully the Wi-Fi is working. But essentially what this is doing, right, is using the Dapr service invocation APIs to call into the, this is running on GKE right now, calling into the AWS, in this case they're K3S clusters, calling into the first one. And so this like invoke endpoint is specific to Dapr. And then we're invoking what's called, in this case, a C# service on the method A based on the message type. So this is like completely normal Dapr. I didn't do anything here to change Dapr. I just am getting the cross-cluster from the Cilium multi-cluster mesh, is my point. And then similarly on the pub sub side. So if we switch to PubSub. Again, I'm going to be routing from GKE into one of my AWS clusters. In this case, the message type defines the topic. So I'm publishing on topic C in this case, and then I am sending this to AWS, and I should see, again, a similar message where I'm invoking that publish endpoint. Perfect, yeah, so PubSub is the name of the PubSub. In this case, we're denoting a Redis message broker, which Manuel talked about on that architecture, and then we are publishing on topic C.
So far, so good?
So far, so good.
So far, so good. All right. But how can we actually prove that what we all said, or what we both said is actually true? So there's multiple ways to do that, and I'll try to walk you through it, and hopefully it will make sense eventually. So this is K9S. I'm pretty sure you all know it. On the left side, there is the one cluster in AWS. On the right side, there's the second cluster in AWS. You could have guessed. And if we look at the front end or at the gateway, we already see those events coming in, right? So this is the service invocation. We called it with the message hello reject. So it's here. On the other hand, there is the publish, so the PubSub to topic C, as Alice said, and there is the message hi GKE to AWS. So the request has reached at least one of the clusters already, right? But how did things come from here, and how did this actually work?
And these are both the AWS clusters.
Yes.
Not the GKE ones. These are both the AWS clusters.
Yes, correct. So if we want to look at a tool I learned about yesterday, which is called Redis Insights, port forward. Typical. Let's quickly. Well, actually, I show you like this. If we look at what Alice said, there is the components in Dapr, right, which control where data is persisted or where times of things are loaded. If we look at the ones, here's PubSub and state store, right? If we look into one of those components in detail, we see that it's looking up a local resource, right? Like it's always looking up, in this scenario, Redis master, Redis service cluster local, it's a local endpoint. So this means we need to have a local service, right? If we look at the services, in here, we see that indeed there is a service, but if we look at the selector, this is like bogus, right? Like no, there will nothing matching on this key pair. What is important though is the annotations, right? So you can see there it is marked as a global service, and it is marked as a global service on both clusters, which I'm pretty sure will not surprise you. Here we go. It's also marked a global service here. What changes though is the way how we split traffic. So on the one cluster, I give it an affinity and tell it, all right, please always use a remote cluster, because I tell it it's not preferred, but we use it to force it, right? So this one will always go to a Redis on a remote, while on the cluster where it actually has the Redis running, it only has the global service annotation. So traffic will always be split or forwarded in terms of Redis connections from this cluster, from this little shiny cluster, to this little shiny cluster. But did it actually work? Like, do we have data in our Redis? As you can see, I just did a port forward to the second cluster for Redis Insights. So let's hope we do see something now. What we learned today is that sometimes rebooting this thing is the best idea. There we go. And there we go. So there is the data. I'm not sure if you can actually see this. And I'm not sure how I can zoom in here.
So essentially what's happening there, right, is like this is just connecting to the Redis clusters, or one of the Redis clusters, which is running both the message broker as well as the state store in this case. And then Dapr has the idea of what's called an application ID. So it has an inherent built-in identity. And that's why you see C# service in there, because that is the service that's being invoked by GKE in this case, as well as we have Python subscriber, which is a subscriber application to the PubSub, in this case written in Python. Again, Dapr is super polyglot, so it doesn't actually matter what languages we're written in. We just had written that as an example, and then each of the streams is specific to those topics within Redis streams.
Correct.
Cool.
And as for the state store, as Alice said already, if we check the actual state store component on one of the clusters, just as an example, right, doesn't matter at that point, and we look at this, we also see the same. So like from the Dapr perspective, Dapr really thinks it's a local endpoint, it's his Redis running on his cluster, and Cilium takes care of forwarding all the things to the other cluster as we thought. But there's another cool way how you can actually show this. And I'm pretty sure that for those of you who use Cilium already, you know about Hubble, right? Hubble is like a shiny little, well, not really little, but a shiny UI to illustrate traffic flow. So if we look into this and we select the namespace of our applications, we can see, now comes the fun part that we practiced yesterday, how to zoom in properly and not screw everything, that we have those services that we talked about, right? You can see on this little dot here that those are running on one of the clusters, so ECS, K3S, doesn't matter, and that there is the sidecars, on the other hand, which facilitate communication, right? And if we pick one of those on those lines and we scroll way down, we see that those sidecars go to the Redis, right? And as you can see here, it also detected that this is running on the second cluster. So Cilium is really taking care of all those moving bits and pieces by rewriting the packages and all the things to move things here. Why would you do that? I mean, this was kind of like a fun example, right? But you could also utilize this for fault tolerance, for example. Like if you mark a service, if you take a service, mark it as a service, but don't screw with the traffic affinity as I did, then you could do you could use it to improve visibility, make it more fault tolerant, right? Because Cilium will see if one of the services, one of the clusters is down, it will forward all the traffic to the running replicas in the other clusters and things like that. So there's really a lot of ways how you can interact and how you can leverage these capabilities. And since it's so transparent from the Dapr point of view, your application developer won't have to care, right? Like your typical application developer just develops against the Dapr SDKs. And for like those ops guys, platform engineers, I mean, it doesn't matter what tech you put on them, but those guys have like the full control of building those fault-tolerant applications. Even like, we could show some more, like we could do some more publish subscribe at that point in time, for example. But you've seen that there is that on the graph, on the Cilium graph, that it forwarded the traffic. So even if I now did some messages, and we look into the logs from the application, we see here's 555. This was the last one we did. If hello console. Now, if we look into the log here, there we go. We see the others, right? 444, 222. So it really, like, requests will land on both clusters again, and all super transparent at that point in time. Thanks, demo gods. I was expecting something to screw up, but at least this does not happen for now.
Just your desktop.
It's just the desktop, but that's okay. Because usually I use it in list view, right? So it doesn't matter how many items are stacked on each other.
So I guess just like to close, if you go back to the architecture for 1 sec, just to close on the architecture, right? Like, so what you kind of saw today, in case that was all a lot of K9S, the front end, again, was running in this case on GKE. This was, again, completely Dapr, transparent, not necessary, had no idea that Cilium exists, but we are calling into one of the AWS clusters because we have Cilium multi-cluster mesh running there. It is acting as if those two, in these case, K3S clusters are the same. And then we have Redis only running on one cluster there, being used for both the Dapr state and PubSub APIs as the message broker, as well as the storage key value store. And then, yeah, that's kind of it. You can intentionally run this on any cloud. So you could swap out one of these AWS clusters or GKE clusters just by swapping out those components, those Dapr infrastructure components, as I talked about earlier.
the fun part.
Okay, yeah. And that was mostly it. We just wanted to say, come by. We'll be at KubeCon all week. Come by the Diagrid booth if you want to learn more about Dapr. Or we also have a Dapr booth, many booths that talk. We'll all be wearing Dapr shirts. You'll see us. And we also have a party on Thursday that we're doing with Upbound, which is a Kubernetes arcade night. So if you want to join the Boom Battle Bar, I'm not sure why it's called that. I didn't choose the name. But yeah, stop by, and thank you so much.
Thank you so much.
A lot to digest. Great talk. Questions? Okay. No questions.
So either I was expecting something from you.
Yeah.
Do you need a mic?
I don't actually need a mic. It's okay. For the stream. Oh, you need it for the stream. Okay, then. So first off, thanks very much for the talk. It was great. I'd be interested in your take on building a multi-cluster between two different data centers, because I mean, if you're just using AWS, it's fairly simple with VPCs and everything. What would your take be to gain local visibility, which as far as I know you need to build multi-cluster? If you're building it, say, between GKE and AWS, what would you use as a tunnel?
That's a good question. I think it depends on what kind of environment you're running in then, right? Like you will need some sort of layer in between. What I see if customers that I work with do is they use WireGuard to wire the nodes together, like to allow for the private IP endpoints and stuff like that. So far, that worked pretty well, at least in the examples, or in the clusters and environments we are running. But I would not go for this is the golden bullet. Like it's one solution I saw working. There's probably more. I would also be curious to see them, but like my first experiences so far is with WireGuard as the foundation, and that worked pretty well.
I've also had a few customers using an open source tool called Scupper. This was like very Dapr specific, yeah. And there's a full Dapr community call on this. It's like SKUPPER. But we have a couple users that are using that for Dapr cross-cluster communication, but it doesn't have to be Dapr specific. It's just an open source project. Yeah, no worries. Good question. Happy to answer questions after too.
So I'll catch up with you and Maurizio sometime this week to talk about how you could integrate Dapr and something like Kratix for doing opinionated provisioning on multi-cloud, multi-region, multi-cluster.
Yeah.
How to do that. Is, high level, is it possible?
From a provisioning perspective, there's really good integrations with Crossplane. Like we work a lot with Crossplane for the provisioning perspective, because Dapr doesn't do any of the provisioning, right? It's just the connectivity. Yeah. But like totally, it's very popular. I would say there's also some integrations with the Humanitech product, Score, and the open source one there. That's not a provisioning. I believe that also has to be provisioned, but it has the whole app package definition, description there. But as far as Kratix goes, I don't know. I haven't come across that in terms of my customer work. Yeah.
Thank you very much.
Cool. Thanks, guys.